Okay, everyone. Welcome to the ISC Student Cluster Competition opening ceremony. We're just starting. So this is our 15th competition. I have with me Brian Sparks and Nages Slack, right? From ISC and Brian from NVIDIA and HPC Advisory Council. Welcome. You want to say a few opening words, Nages?
Yeah, I can't believe it that I've known you guys for 15 years. Doesn't feel that long ago. It just reminds me how, much older I'm getting. This is a fantastic competition. I feel very honored to be part of it. I've seen so many students come and go, and just like Fong, who is a judge on this competition, she started at ISC as a student volunteer. And I'm not sure if Fong has been part of the competition, but she saw the competition and decided to be a judge of it, and has been with the competition for many, many years
Yeah,
now.
she
And
was. She was in 2019, right? 2019.
2019, wow, yeah,
Part of the competition in 2019 as a student.
amazing. So yeah, and then I keep seeing people now in suits coming to ISC who are now managers running into meetings. So it's a very exciting competition. It's really a doorway. It opens doors to students to high performance computing as well as the community. Our event, the live event. There we expect about 3,500 people. It's not very big, so it allows the students who come to the ISC competition to actually make connections with all the people that they need to meet, and who can help them with their studies, with their PhD programs, as well as their careers. Yeah, and I can't remember, no longer remember, excuse me, when we started the online competition. I think it was COVID, wasn't it, when we started the online competition?
Yeah, due to COVID, we had this idea to start online because no one can no one can join. We had a virtual
Right.
IC.
So that has been 6 years we are doing the online competition. So it's amazing that, we have these virtual teams, and that the competition is steadily growing. I think the numbers have been fluctuating between 20 to 25 teams per year. Yeah, this is exciting. I have some information for the on-site teams, but I think I will not overwhelm anyone
Yeah,
with those information. That we will put that on the website.
sounds
Yeah.
good. So this year we have 31 teams. That's a record number, and 21 different teams participate in the virtual part, and the other 10 different teams in the in-person part. That makes it about 180 students or so, which is quite a lot of you, quite a lot of students participating, and we do hope they will gather the most out of it. Okay, let me continue. So this competition we couldn't have done without sponsoring from URCA, yeah, all right, University of Reims, Champagne, Ardennes, that sponsor us with the Romeo cluster, which is a Grasshopper nodes, and the Iris cluster from the HPC advisory cluster that we manage. And we have with us Arnaud, right? I spell your name right, is managing the director of the center, the Kulkar Regional Romeo, as I would say, and managing the clusters over there. Romeo, do you want to say a few words to the teams? Arnaud, sorry, Arnaud.
No, thank you, Firas. Thank you very much for welcoming us in this competition. We are very, very happy to provide resources for the competition. We hope all the students will learn a lot to use our supercomputers, and already sent the password yesterday and the logins. I also send the bad link, so I make an announcement on the Slack, so we can meet on the Slack if you have any questions. And I want also to thank everyone organizing this competition. So thank you, everyone. And I want to thank my team, and Fabien should be there somewhere because they are making a great work to make this work. And thank you, everyone, and good luck.
Okay. Thank you, Arnaud. And we continue with our great thanks to our sponsors. We have Weka as a Docker sponsor and Huawei as a Magister sponsor. And with Weka, we have Bonnie, right? Bonnie Bruno, the Director of Product Performance Engineering. Do you want to say a few words?
Sure. Thank you for the invitation. We're very proud sponsors. As if you've been paying attention, Weka is a high-performance storage company, and storage has taken center stage literally at CES and NVIDIA's GTC conference last week. So I'm coordinating the storage competition this year at ISC. Looking forward to meeting all the students. So thank you very much.
Thank you. Thank you, Bonnie. Again, this is our logos from all the teams. So if you are there, look for your logo. And again, good luck on the teams. This year, we're going to have 4 applications and 1 AI task on the virtual part. For the in-person, we will have the HPL, the storage task with the FIO and HPCG, and a secret app. So going to be a lot of work, and again, we hope you will take that and enjoy the past and learn out of that. We'll start with OpenFOAM. We have the session tomorrow, but do we have Mark here, right?
Yep. Hi, Fear. Hi, everyone.
So Mark is a principal software architect at NVIDIA. Mark, do you want to say a few words?
Yeah, sure. Excited to be here. It's my first year as a judge in this competition. Really looking forward to this experience. And a few words about myself. I've been working with OpenFOAM for about a decade, I think. Very passionate about improving the software and being part of the open source community that develops OpenFOAM. You'll hear more about OpenFOAM tomorrow when I present it to the students, but it's a very nice piece of software that's entirely developed by people from the open source community. And it's very widely used, but it does have a lot of tweaks and a lot of place for optimization, a lot of room for optimization, which I'm hoping you guys can find and really teach me as well how we can get the best performance out of OpenFOAM. So as Ophir mentioned, I'm currently with NVIDIA, working mainly in the optimizing NVIDIA's networking stack. But my background is in computational fluid dynamics, which OpenFOAM belongs to the class of software that simulates computational fluid dynamics. And I'm personally passionate about this field, and again, really hoping to enjoy this experience and working with you students and in the committee. Thank you.
Okay, thank you, Mark. And next application, and we have with us Consta and Matthew about ASCOT 5. Do you want to say a few words, Consta?
Yeah, I can start.
Let's start with you. Matthew, you can join as well.
Yeah, I can start. So yeah, nice to meet you all. So I'm Consta. I'm a plasma physicist working at the VTT here in Finland. So we are developing here in VTT. We are developing this novel energy source, fusion energy, and that's very computationally heavy field, or we rely very much on modeling because these experiments, they are very expensive. So one of these codes that is now widely used is this ASCOT 5, which is fulfilling a very specific purpose in the field. But I will talk about more that tomorrow. So if you have any questions about this ASCOT 5, just be gentle. It's still working progress code in a constant state of development. But anyway, if you have any questions, you can ask me or then Matthew, who has been great help in GPU porting of our code So if Matthew wants to introduce himself, go ahead.
Yeah, thanks, Consta. Thanks, Sophia. So hello, everyone. So I work on ASCOT 5.2 with Consta. So I'm at EPFL in Switzerland. I work on optimization of HPC code relying on fusion, nuclear fusion, and I'm specifically involved in the GPU porting. So as Consta said, ASCOT 5 is widely used in this field of fusion, and so we are happy that you can use this code and look forward to your feedback on it. And so enjoy with the competition, with the code, and with ASCOT 5.
Okay, thank you guys. Thank you guys. And moving on to DFTB Plus, I know Balint could not join this week, is off. We had the presentation last week, and we have Ben with us. Ben, do you want to say a few words?
Yeah, sure. So, well, it's very great to be here. It's new to ISC as well for us. And congratulations to all of the student teams. So we look forward to seeing how you're going to get on with this. As Ophir mentioned, the slides and the presentation from last week are on the wiki, so you can download that and have a look at it. And we're obviously going to be on the Slack channel for this. So good luck, everyone.
Okay, thank you. Next, we have John Makulo, right? Am I saying it correctly? He's a lecturer from the School of Mathematics. He's leading our MLB. John, do you want to say a few words?
Yeah, no worries. Thanks, Fia. Good day, everyone. Welcome to the competition. Hope you enjoy it along the way and learn a lot of things. So I'm working with the MLB code. I've been working with the code now for 6-7 years now. So like the OpenFOAM code that was mentioned earlier on, it solves computational fluid dynamics, but it does it in a completely different way to what is done in OpenFOAM. So hopefully it'll be interesting to see the comparisons of performance that you can get between the two codes and understanding how two different approaches work. So HemeLB is tailored for biomedical flows, in particular blood flow in complex geometries, but I'll be giving a talk tomorrow to give more details on all of this stuff. So thank you very much, Afir, and all your organization, and best of luck to everyone.
Okay. And fifth task for the virtual teams, we have Fong and Suda from NVIDIA. Fong, do you want to say a few words?
Hi, hello everyone. So my name is Phượng and I'm a performance engineer at NVIDIA. As Ophir mentioned, I participated in the competition at ISC 19 and participated at the conference several times as a student volunteer. And this is my co-worker, Sudhakar.
Hi everyone, my name is Sudhakar. I've been working at NVIDIA for about 5 years now. And I've been working on optimization of deep learning models. I'm very excited about the AI task, which Fong is going to mention more about.
So this year we bring to the competition 2 AI tasks. The one for the virtual competition is distributed LLM training with MathText. We will have an introduction section after this virtual open ceremony. And for the on-site competition, we will introduce to you guys another task, which is high performance LLM inference with Llama CPP. So join us to learn more about the virtual task after this ceremony.
Okay, thank you, Fong and Sudhakar. And we have Bonnie again with the storage task. Bonnie from Weka. Bonnie, do you want to say a few words about the task? Just like a 1-minute pitch.
Sure. There's so many benchmarks out there for storage. Supercomputing obviously has IO 500, but for this storage competition, you're going to focus on optimizing a shared storage system that mimics certain IO patterns that are common in for AI training and inferencing. So to keep things simple, we'll be using FIO to explore how performance behavior across sequential throughput, random IOPS, multi-node scaling, the key here isn't just the raw numbers, but it's understanding how parameters like block size, queue depth, concurrency interact with the environment. So looking forward to working with the students, have fun with this, and push your storage to the limits. Thank you, Ofer.
Okay. Thank you, Bonnie. And now we're going to move to some general things, general topics. So first, you should all be aware, I send it in the Slack all the time. Look at the agenda. It's mostly fixed, but it might change. And most of the time it's fixed. We have the presentation details there with the links. So use it, join us, try to learn and ask questions if you have. So that's the agenda. Cluster access. Today you're going to get the details from David Shaw about the Iris cluster probably in your team channel, and look for email from Arnaud about the Romeo cluster. He sent it, but he's going to send another one to fix the broken link. So look for that. And again, if you have any issues, don't hesitate, don't wait. Send us a message in your team channel on the Slack so we can help you. Slack channel. This is our main way to communicate with the teams. Make sure that at least one team member, maybe team captain or someone else, is monitoring the Slack for general messages, especially now when we are starting. We will have, anything that can occur. I hardly send emails to the teams because just too many students. So we use the Slack channel for the main way of communication. You should monitor your own team channel and the main channel. That's the main two channels that you need to monitor. General question you can ask in the main channel, and private questions in the team channel. And again, don't stack. We had that in the past, teams that didn't know what to do, didn't ask, and they got stuck. So if you get stuck, don't hesitate, talk to us. We'll try to help what we can. Okay, team presentation. I will send later on around April specific slots of time. Each team will get a 40 to 45 minute session that you will need to present your work, and we will have the developers and other judges join and listen to you and ask your questions. Team folder. I will send it to you later on, but your work should be uploaded there, and we're trying to set up also another folder on Romeo cluster. Arnaud will send you, me and Frank send you an email about that. We can see if we can generate folders for the teams on the Romeo cluster to make it easy not to upload too much of gigabyte outputs outside. So look for that. At the end of your work, eventually you will need to submit your work and upload your team presentation to the OneDrive. So look for announcement about that. I couldn't make it, or we couldn't make it without the help of many people, including all the developers and other committee members that are continuous helping every year. So I want to thank everyone. Thank you guys. And it's some work, and it's a nice process for everyone to walk through, even the judges, And of course, I want to thank very, very much to the team advisors for all the teams to help leading the teams. All the virtual teams that we have. So quite a lot of people are involving here, pushing the students forward, and the teams, the advisors from the in-person teams. Again, quite a lot of teams, and there's a lot of support that those teams are needed to move forward. Okay, and teams, we are just starting now today. So I want to congratulate you and say good luck to all the teams and try to start. I would say that in the past years, many teams used the last 2 weeks to work on the task. I would say don't wait. Use the whole amount of time we allow in the clusters, and so you'll have a lot of time to work on that, to debug. Don't wait to the last 2 weeks. Then it becomes too crowded and very busy on the cluster, and sometimes things get hard to do. Use all the times. You have about a month and a half, so use that. And after the presentation, after we get all the results, we'll have the award ceremony on ISC event in June. So join us if you are coming. Join us there. We'll announce the winners of the virtual and in person on the award ceremony on ISC. And if you are on X, you can use the hashtags to discuss, put pictures or social with those hashtags, IC26, IC26 Student Class Competition, SCC. And Najas, do you want to say a few last words before we close?
Sure. Yeah. Just wanted to say that thanks for mentioning the closing ceremony, which is on the last day of the competition. That's June 25th.
Yeah.
And anybody can come as long as you're registered for the event. You can be a holder of an exhibition pass or a conference pass. Yeah, really excited about this competition and look forward to welcoming the 10 teams in person at ISC. And yeah, good luck to the online teams.
Okay, so that closes our opening ceremony. This is just the highlights. In about half an hour, we'll start with the AI task with Fong and Sudhakar. So join us on the Teams invite. Okay? Okay, everyone. Good luck. Bye-bye.
Thank you.
Bye-bye.
Good luck, everyone.
Good luck.